Welcome back to the Chem OG. Today we're going to be talking about stereoisomers. And the word stereo just means space of some sort. So stereo sound fills up the entire room, right? It fills up all that space. A stereotype is really bad because there's plenty you don't know about a particular person. And so you're filling up that space with things that you may have known or seen or comprehended somewhere else. And so those stereotypes can be harmful for that reason because you don't have full knowledge of that particular person. So stereoisomers have to do with isomers and filling in space on those isomers. So remember that isomers are molecules with the same molecular formula. Stereoisomers have the same molecular formula and the same functional groups. But what's different about the stereoisomers is that those functional groups spatially are not in the same place. So there's that word space, is that these isomers have functional groups that are not spatially in the same position. So let's take a look at a couple of examples. If I take a look at the molecule on the left and contrast it with the molecule on the right, we begin to see two main differences. The first difference is that the hydroxyl group on the left that's on a wedge is actually on a dash on the other molecule. So on the hydroxyl group on the left is coming towards us, whereas the hydroxyl group on the right is moving away from us. And the other place that I can take a look is at the double bond that's all the way to the right. So that double bond that's all the way to the right, I notice a difference there when I contrast it with the molecule that's right next door on the right-hand side. So the amide functional group, this one right here, is in this molecule, it's oriented away from the remainder of the molecule. Whereas if I take a look at that same amide functional group over here, it's oriented towards the rest of the molecule. So spatially, that double bond and the way those atoms are connected is different, even though all the functional groups match up in the same exact places on the same exact carbons. So this would be an example of two molecules that are stereoisomers of each other. So when we talk about stereoisomers in a very practical way, in order to form one stereoisomer from another, what we have to do is we have to break bonds, and then we have to switch out where those atoms are located with respect to a particular carbon. And so it's not a simple matter of rotation. If I take a look at that hydroxyl group that's on a dash here, in order to convert it to one on a wedge, I can't just, take this molecule and rotate it towards me. Everything would be in a totally different place. So what I would have to do is I would have to break this OH bond, and I would have to also break the bond to the hydrogen on that same carbon and swap those two, right? What I would have to do with this double bond is I would have to break that double bond, and then I would have to rotate this carbon down here and then reform the bond again. Right? So again, it's not a matter of rotating the molecule. You physically have to break bonds and reform them elsewhere. And that's a really good way of taking a look at stereoisomers in general. And so stereoisomers, because they have the same functional groups, and those functional groups are on the same carbons, they're going to have very similar properties. But when they do have differences, though, or in the differences that they have among them, sometimes those differences can be very, very impactful. So to give you an idea, there's this molecule called thalidomide. And thalidomide was a drug that was sort of introduced to the market in the late 50s and in the early 60s. And one of the uses for thalidomide was that it was used to treat morning sickness. And so thalidomide can have this stereoisomer right here, in which the ring on the right is towards us, or it can have this stereoisomer right here, in which the ring is away from us. So one of them is the R absolute configuration, and one of them is the S. And you can check out another module coming out to you soon about how to assign R and S absolute configurations. But the isomer that's on the left is the one that's bioactive, right? That can be used to treat morning sickness. Whereas the molecule on the right is actually quite dangerous because it can cause birth defects. And so, again, in the late 50s and into the early 60s, there were tens of thousands of children who were born with birth defects simply because we didn't realize that even if you did take only this version of the drug that's, quote unquote safe and doing what it's supposed to do, it can convert in our bodies to the other isomer, which can be quite harmful. And so there's a very much a biomedical aspect to learning about stereoisomers that can be really useful. So again, stereoisomers have these practical applications. Let's take a look at certain types of stereoisomers. So the first type we're going to take a look at is ones that are mirror images of each other. So what I mean by mirror image is the following. So imagine with me that we're looking at this imaginary human-like being. And so this being has a heart on the left side of the body. So this being is facing towards us. So whatever's on our right is that person's left-hand side. So has a heart on the left side of the body, has a white kidney on the right side, and has a left kidney that is black. All right, so if I take a look at the mirror image of that person, in other words, if this person or if this being were to stand in front of a mirror, everything would be flipped. So whatever is on the left-hand side becomes on the right, whatever's on the right-hand side becomes on the left. So you'll notice that for the mirror image, this other being, the heart is on the right, the black kidney is actually on the right, and the white kidney is on the left. So those are not the same being, right? They have characteristics that are different. Now, functionally, I expect them to function the same way. So, it's like, hey, your heart's on the other side and each of the kidneys are swapped. Everything is swapped. So I kind of expect you to function in the same way in terms of internally what it is, that's going on inside your body. And so we have a particular name for mirror images that are not exactly identical to each other, but we expect to behave in a lot of identical ways, and those are known as enantiomers. We'll take a look at enantiomers in another module, but enantiomers are what we call these mirror images that are not exactly the same, but we expect to function in a lot of identical ways. Another type of stereoisomer is going to be ones that are not mirror images of each other. So back to what we were saying earlier about these two beings. What if I had another being that instead of the heart being on the left, for this other being, it's on the right. So those are flipped. But then the kidney that is on the right is white in both beings, and the kidney on the left is black in both beings. So I don't expect those two beings to function exactly the same way, because it's not like the other two where everything was flipped. It's some things are flipped, but some are not, right? So there must be some sort of different function about these two humans or two beings that are not exactly the same as the pair of mirror images we saw from before. So whenever we have that scenario in which some things are different, but not necessarily all of them, we are going to call that pair of stereoisomers, we're going to call them diastereomers. So we saw two types so far. We saw ones that were mirror images of each other. We expect them to have a lot of identical aspects. And now we've seen ones that are not mirror images of each other, and we expect them to be similar in a lot of ways, but we also expect them to not exactly behave in identical fashions. The third type of stereoisomer we're going to take a look at is ones that are very different, and these are going to be fused mirror images. So if we take a look at that same analogy that we saw, right, with the two human-like beings, this would be a new being in which two things are fused together, right? So I got two humans side by side that are mirror images of each other, but are connected to each other, right? So they're very much the same being. And that is something that we're going to call a meso compound. So meso compounds are quite different, right? But they're going to be mirror images that are fused together. So this was the first lesson and an introduction into stereoisomers. We'll be taking a look at those particular stereoisomers that we talked about, enantiomers, diastereomers, and meso compounds in a different module. Thank you for watching today's lesson. Don't forget to like and subscribe.